In this adventure RPG, the challenge I'm facing isn't making enemies numerically stronger, but making their behaviors more intelligent. Today, I'll be showcasing the AI system that drives all of this. First, there's visual perception. Enemies have real vision. Only when I enter their forward cone-shaped field of view will they detect me and start chasing. If I manage to escape, the AI doesn't reset. It records my last known position and enters a search state, which greatly increases the game's tension and realism. Second, there's auditory perception. My attacks generate sound waves. This alerts nearby enemies, forcing me to always be aware of my surroundings during battles and formulate tactics. Defeating AI enemies is just the first step. It's through the challenges posed by these intelligent enemies that players earn the right to progress the story. For example, after clearing an area, a witch will talk to me and teleport me to a more dangerous region. There, I'll encounter enemies with more behavioral patterns and at the same time find more powerful weapons and potions. Now, let's dive deep into the code to see how all of this is implemented. First, here's an enumeration defined, which is like the brain modes of the enemy AI. It explicitly specifies that enemies can only be in one of four states: patrolling, chasing, attacking, or searching. This is the core of what we call a finite state machine. Right after that, this state machine update method is the decision-making heart of the entire AI. It runs every frame of the game, executing corresponding behavioral logic based on the current state. The key to intelligence lies in perception. Take a look at this can-see player method. It uses physics raycasting to check for obstacles between the enemy and the player, and combines that with field of view angle calculations to determine whether the enemy sees the player. This forms the visual system one demonstrated earlier. When the player successfully escapes, the AI doesn't lose its memory. Look at the search behavior method. Here, the player's last known position is stored in a variable, and the enemy is ordered to move to that location to execute the logic of looking around and searching. This is what creates that tense and realistic manhunt experience. In summary, by building a robust state machine architecture and endowing it with the perceptual abilities of vision and behavioral memory, I've successfully transformed enemies from static level obstacles into dynamic cores that can drive the game's progression. It's precisely through battling these intelligent enemies that players gain the right and motivation to advance the storyline, explore new areas, and ultimately challenge stronger bosses.